Okay, the depth of water in a harbor T hours after midnight can be approximated by the function la 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 la. So this is written funny that 12 should be on the tail end like so, plus 12. That's our midline value. So what's happening is, in this harbor, on average, the water is 12 meters deep. But because of tides, because of the moon's gravity slightly shifting the water all over the Earth's oceans, the water gets deeper and shallower as the day goes by. It can get up to 5 meters deeper at high tide, so at some points during the day, the water is going to be 17 meters deep, and at other times during the day, the water is going to be 5 meters shallower. It'll only be 7 meters deep. So our midline is 12, the amplitude is 5, so we go up to 5 meters up, 5 meters down, and we call those high tide, and the 7 meter would be low tide. So the amplitude and equation of the midline here, despite they wrote it kind of flaky, but we fixed that. So the amplitude is 5, the midline is y equals 12, and the minimum and maximum we got already. The max is 17, the minimum is only 7. Determine the period to the nearest tenth of an hour. Well, our b value is 0.524. So the period is 2 pi divided by 0.524. Two pi divided by 0.524. So to the nearest tenth, it's 12. And that's because of the 24-hour rotation of the Earth. The Earth is approximately a ball, but the oceans bulge out on the side nearest the moon, and they also bulge out on the side opposite the moon. So every 12 hours, one of these bulges is going to pass over you. That's how you get a 12-hour period for the tides. Write a suitable window that can be used to display the graph of the function. Well, if you wanted to show an entire day of this, you'd probably want to go from 0 to 24 hours. And for the depth of the water, you could go 7 to 17. I'd be inclined to use something like 0 to 20, just because I like starting graphs at 0, and you don't want to stop right at 17. You want to have a little extra space, so when the calculator starts displaying stuff up here, it doesn't run over your graph. So x min 0, x max 24, y min 0, and y max of 20 at least. Use the graph of the function to determine to the nearest tenth of a meter the depth of water at 2 p.m. Okay, I guess they expect us to graph this now, so let's get that happening. This graph is, I'm going to put the 12 on the end because it bugs me that they wrote that out of order after we spent days and days showing you how to write these correctly. 5 sine 0.524x plus 1.571 plus 12. We're in radian mode, that is good. Oops, I forgot to fix the window. Alright, dumb graph, please ignore that. 0 to 24 hours, so we see an entire day. And we'll go from 0 water depth up to 25 meters of water depth in steps of, 5. Low tide, high tide, low tide, high tide. Okay, so that's what the water does during a day. And they're asking, how is the water at 2 o'clock p.m.? Well, T is hours after midnight, so it takes 12 hours to get to noon, plus 2 more hours. They're asking about 14 o'clock. Trace value. At 14 o'clock, the water is 14.5 meters deep. Next, a ship that requires a minimum of 8.5 meters of water is in harbor at midnight. When must it leave to avoid grounding? So this ship is in here. The water's 17 meters deep, but now the water's coming down, and if this ship stays here too long, we'll end up with only 7 meters of water in the harbor. This ship has an 8.5 meter draft, so it will run aground and possibly be damaged or capsize if it sits here too long. When is 8.5 meters going to happen? Let's see. Right there. This is the bad spot by which this ship has to bug out into open water, or else the water in the harbor is going to get too shallow for it. So when does that happen? If we go second calc, intersect, enter, enter. Careful where you put your guess. There's a lot of intersections on a sine wave. We'll get it way over here. 4.47 hours after midnight is when this ship has to leave. Now, that does not mean 4:47 in the morning. To get this right, you have to do 0.47 hours times 60 minutes in 1 hour. .47 times 60, 28 minutes. So 4:28 a.m. is when it would have to leave. Now, they say to round to the nearest 10, or they say to round to 10 minutes. Would you tell these guys get out by 4:30? That sounds like a really bad idea, because what if they get out at what if they plan to get out at 4:29 and they don't make it because you rounded this the wrong way? If a big expensive ship were relying on me for instructions here, I would take this 4:28 and roll it back and say, no, play it safe, get out by 4:20 if it has to be to the nearest 10 minutes. 4:30 would be a little bit too late. 4:20 will get you out with with 8 minutes of safety margin. That's the way you want to round when it's important stuff. And what is the next time to the nearest necessary 10 minutes that the ship can return to the harbor? Coming back to our graph, the ship has to be gone here, but it only has to be gone for this little bit of time, and then the water gets back to 8.5 meters deep, and it's nice and deep for over lunchtime and well into the afternoon. So right here is when the ship can come back in. Where's that? Second trace, intersect, enter, enter. Just move your guess over to the intersection point you want. Turns out that one's 7.51 hours. 7.51 hours. Again, that doesn't mean 7:51 a.m. That means 0.51 hours times, there's 60 minutes in 1 hour. 0.51 times 60, 30.6, basically 31 minutes. So it's going to be 7:31 a.m. is when the water is deep enough for this ship. So they have to be gone from 4:28 to 7:31. Now again, if you had to round this to 10 minutes, you don't go to 7:30 because that would bring them in a minute too early, meaning they might hear a horrible grinding noise as their ship catches the bottom. If you have to do to a 10-minute value, give them a little bit of a safety cushion and tell them be back, but stay out until 7:40. By 7:40, you'll be 9 minutes past and the water will be definitely deep enough. 7:30, you're cutting in by a minute and you risk causing a problem by rounding the wrong way. So there's round to the nearest number and then there's round to the safest number, and they are not always the same thing. Here we're giving the ship extra time, or we're telling it to stay out of the harbor for a little extra time to make sure that the water's good when it comes back.